So in this video I'm going to solve now the final part, which is part C. So part C, we are looking for if the spring is compressed by only 0.30 meters, find the change in the mechanical energy due to friction. So part C is requiring us to calculate now the work which was lost, or the change in mechanical energy simply means the energy which was lost due to friction. So here is where now the third and final concept to apply, the work energy theorem. So the work energy theorem states that the work done by non-consecutive forces is equals to the kinetic energy of the object plus the potential energy, the gravitational potential energy plus the elastic potential energy final minus the kinetic energy plus the potential energy or the gravitational potential energy plus the spring, the elastic potential energy initial. So here you have to subtract the initial from the final. So now here, if you go back to the diagram, the simple diagram, we know that we knew that the final energy the car had was the elastic potential energy due to the spring, because the car stopped and the only energy that was in form of kinetic was transferred into elastic potential energy. So we know that when the car was when it reached its final point, it stopped, and also it was at the ground, which means it didn't have the potential energy, or the gravitational potential energy was also 0, but it did have the what? The elastic potential energy. Then you subtract. Initially, we know that the car was at the top of the hill. So the car was at the top of the hill. So it only contained the gravitational potential energy, which was due to gravity. The rest of the energies were 0. So the kinetic was 0, but it had the gravitational potential energy, and the spring was also 0. So if you remove the zeros, you have half kx squared minus mgh. Then here you have the values. So you can say 1 times everything on top. You have kx squared over 2 to simplify things for you, minus mgh. Then the spring constant, you know, it's 1 million multiplied by here the distance. We don't use the distance in the first equation. No, we use this distance they gave us. They said that if the spring is compressed only, so if the spring was only compressed by what? 0.30 meters, what is the, so here the distance is 0.30 meters squared, divide by 2. Then you subtract 13,000 newtons times I8, which was 10.0. So if you punch, well, you should get approximately a number like 85, 8 85,000. Yeah. Yeah, so approximately you should get 85,000 joules, which is also negative because this will be bigger than this part if you punch well. Yeah. So, since in physics this answer doesn't look good, yeah, it's too big. So in physics, they have introduced, that's why you learned in semester 1 scientific notation, significant figures, those things you learned them to use them. So here you can say now, how can I represent this number into what?